Hey guys, we're going to take some notes right now today about z-scores using our normal curve. This is going to go in our digital notebook on slide 11 through 15. I'm actually going to start with an example. So if you guys can go over to page 24 in your workbook, we're actually going to start with an example. It says example number 4 says the manufacturing specifications for nails produced in a machine shop require a minimum length of 24.4 centimeters and a maximum length of 25.2 centimeters. The operator of the machine shop adjusts the nail making machine so that the machine produces nails with a mean length of 25 centimeters. What standard deviation is required for 95% of the nails to meet manufacturing specifications? Assume the lengths of the nails that produced in the machine are normally distributed. So that means it's going to follow that normal curve. So in the middle, it tells us that the mean, it's normally distributed. It has a mean length of 25 centimeters. So here's 25 centimeters that goes in the middle. And then normally what we do is we would take and we would add the standard deviation 3 times to the right and subtract it 3 times to the left. Well, we don't know the standard deviation. It didn't mention that. It just says that they want 95% of the nails to meet the specifications. Well, the specifications are that it has to be between 24.8 and 25.2. So like I said, normally we would add 1, 2, 3 standard deviations, subtract 1, 2, 3 standard deviations. Well, 95% means 2 standard deviations, right? 2 standard deviations away from the mean is 95% of your data. So what we have here is 24.8 and 25.2 would be your minus 2 standard deviations and your plus 2 standard deviations to get 95% of the data in between those two numbers. Well, then if we know that 25 plus 2 standard deviations, whatever they are, because the question says what standard deviation is required, it's going to be equal to 25.2, okay? Because if I add 2 standard deviations, whatever they are, I would get to 25.2. So I'm just going to solve that. So I subtract 25 on both sides. I get 2 standard deviations is equal to 0.2. Divide both sides by 2, and we get our standard deviation is 0.1, and these are centimeters for our units. Okay, so this was you had a similar homework problem on your homework classwork thing from last block day. All right, so that is the only thing that has to do with this empirical rule. The rest of our stuff that we're going to be doing today is not going to fall under the empirical rule, and I'm going to show you guys how to do those. Okay, so let's start off with our title, notes 1.1.2, z-scores. So what a z-score is, a z-score is just the number of standard deviations a given value lies away from the mean. If you get a positive number, that just means that your value is above the mean. It means it's going to be on the right. If you calculate your z-score and you get a negative number, that just means that the value is below the mean and it's going to be on the left. We have a little formula that we're going to use to calculate the z-score. The formula for calculating z-score is z equals x minus mu over sigma. So x just represents your data, mu is just your mean, and then sigma is just your standard deviation. You could see, instead of mean, you could see x bar, or you could see just m. For standard deviation, you could also see s, the sample standard deviation, so you could see other letters other than these ones to know what it is. But what you do is you subtract your data minus the mean, whatever that is on top, you put your standard deviation on the bottom, and then you divide them, and that will give you your z-score. Positive number just means that if you were, to look at your normal curve, just means that it's on the right, and then if it's a negative number, that just means it's on the left. All right, we have something called the Z-score table that we're going to be using today. Actually, let's go do our example real quick of that. So let's go to example number 1. This is on page 23. We're just going to calculate a Z-score. It says in the 2012 Olympics, the mean finishing time for men's 100-meter dash final was 10.10 seconds. So the mean was 10.10 seconds, and the standard deviation was 0.72 seconds. Usain Bolt won the gold medal with a time of 9.63 seconds. Assume a normal distribution. What was Usain Bolt's z-score? So what you need to do is you need to find 3 things, okay? The 3 things you need to find are your data, that's your x. You need to find your mean, that's your mu, and you need to find your standard deviation. Those are the 3 things that you need. So our data is Usain Bolt's time. So his time was 9.63. The mean finishing time was 10.10 seconds. And the standard deviation was 0.72 seconds. So we're just going to put these numbers into our z-score formula, which is z equals data minus the mean divided by the standard deviation. So when I plug them in, the data is 9.63 minus the mean is 10.10 divided by the standard deviation is 0.72, and that will give us our z-score. So I grab my calculator. Desmos is our preferred calculator, and then I'm just going to go ahead and type in my numbers. 9.63 divided by 10.10. Oops, it's not what the problem was. 9.63 minus 10.10, all divided by 0.72. I get a standard deviation of negative 0.65277778. We always want 2 places after the decimal for z-score, so 2 places, negative 0.65. So you're always going to want 2 places after the decimal. That's the z-score. That just means how far away it is from the mean. So negative means that it's below the mean. Remember, his time was faster. His standard deviation was 0.72 seconds. He was minus 0.65 standard deviations away from the mean. All right, now we're going to talk about how to use something called the Z-score table. So the Z-score table, we have one in our workbook that we're going to use, but basically this is a table that's used to find the percentage to the left of your Z-score. So it's just a table used to find the percent of data to the left of a z-score. So what you're going to see in your table, it's going to give you percentages. There's our normal curve, right? So the mean is normally in the middle. What you're going to be doing is you're going to find a z-score. If your z-score is positive, it'll be on the right-hand side. This table is going to tell you what percent of data lies to the left of that z-score. So the percent from the table is going to tell you from the z-score left. The percent from table is going to be on the left. So let's go do an example. I'll show you guys how to use the table. This is on page 24 for your notes. Example 2 says, what percent of the values in a normal distribution are more than 1.2 standard deviations above the mean? So I'm going to draw pictures so we can help us visualize that. So the mean is normally in the middle. We want to know 1.2 standard deviations above the mean. So above is going to be to the right. This is going to be our z-score is 1.2. So our Z-score table is going to give us the values to the left. But the problem asks what percent of the values are above the mean. Are more than 1.2 standard deviations above the mean. So it's going to want this side. So the Z-score table is going to give us this side. We're going to have to figure out how we find this side. All right, so what we need to do is go to our Z-score table. This is on page 7 of your guys' workbook. So at the top, I want you to draw like just a little picture just to visualize, right? Wherever your Z, this is the positive side. So see how there's a Z right here. How it's going to work is we're going to match a number on the left with a number on the top. So the Z-scores, page 7, is the positive values. So your Z-score would be over here. And all of these numbers here represent percentages to the left. And then if you flip it over to page 8, if you notice all of these numbers over here on the left are negative. So these represent all of your negative Z-scores. These would be ones that are to the left of your mean and shaded down. So notice how all of these percentages are a little bit smaller than the percentages on page 7. All right, so here we go. Our problem said a Z-score of 1.2. So here's how we find our table. We want the positive side because it's 1.2 is positive. So we scroll down until we see 1.2. Okay, so I see 1.2 right here. And then whatever your second decimal is, or second number after the decimal, it doesn't say one, it just says 1.2. It doesn't say 1.25 or 1.27, it just says 1.2. So then we match it with the 0.00 because 1.20, not if it was 1.21, 1.22, 1.23, 1.25, and so on. But we want just 1.20, so it's 0.8849. 0.8849. Oops, what am I doing? 0.8849. So that's the green part, is 0.8849. So it says percent. So if I switch this to a percent and move it 2 decimal places, this would be 88.49%. Well, we don't want this green part, we want the red part. So what you have to remember is that the whole entire thing is 100%. So if I subtract 100% minus the 88.49%, then that's going to give me my above the mean. So it's 11.51%. I believe on your Delta Math classwork, they only want one place after the decimal. So you would just give 11.5 as your answer. I'm pretty sure. All right, we're going to try another problem. It says example 3. If a population of human body temperatures is normally distributed, so we need it's normally distributed, has a mean of 98.2 degrees Fahrenheit and a standard deviation of 0.7 degrees Fahrenheit, estimate the percent of temperatures between 98 and 99 degrees. All right, so if we draw our normal curve, we put our mean in the middle. That's 98.2. So normally we would add our standard deviation 3 times to the right, and then we would subtract our standard deviation 3 times to the left. Well, 98.2 plus 0.7 is 98.9. We want 99, which is to the right. So I'm going to put 99. And 98 is just 0.2 from to the left. 98 right here. So we want to know the percent of temperatures between those two. So between 98 and between 99, we want to know these. Well, these numbers are not -1 and +1 standard deviation, so we cannot use the empirical rule that we used before. Instead, what we have to do is we have to find 2 different Z-scores. So I'm going to find my first Z-score. I'm going to call it Z1, and I'm going to use the number 98. So remember, the way you find your Z-scores, you subtract your data minus the mean, which was 98.2, divided by the standard deviation, which is given right here, of 0.7. So 98 minus 98.2, and then divide that, by your standard deviation of 0.7. So I get negative 0.2857. You only want 2 numbers after the decimal for Z-score, so negative 0.29. So negative just means that we're below the mean, which we're to the left, so that's good. So we're 0.29 of a standard deviation, not a whole standard deviation, 0.29 of a standard deviation below the mean. Then I'm going to find my second z-score. I'm using the 99. So 99 minus 98.2 divided by 0.7. So I'm just going to use the same thing. I'm just going to delete the 8 and put a 9. So I get 1.142, so it's 1.14. We don't round. So this is 1.14 standard deviations above, so more than a standard deviation above the mean. So the way that the z-score table works is it will find us the percent of data to the left. So what I would do is I would have, this is for 98, I would use this z-score, and that would tell me my percentage to the left. And then I would use my table. I'm going to do 1.4, which is above the mean. That's for 99, and it would give me my values to the left. That's what my z-score tables are going to do. Okay, so if I use my first number, negative 0.29, so negative 0.29, I'm going to go to the side that's negative, so that's page 8, negative 0.29. So I go to negative 0.2, and then I got to go to 9. So this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So 0.3859. So I'm going to make it a percentage. So I move the decimal 2 places, and I get 38.59. Okay, that's the percentage to the left here. Then I'm going to do 99, had a z-score of 1.14. So I'm going to be on the positive one now. And I'm going to find the one, let me erase what I had before. It was 1.14. So I go on my thing and I go to 1.1. And then I go to 4. So here's 0, 1, 2, 3, 4. So this is the one I'm going to use. I highlighted too much. 0.8729. So move it as a decimal, it's 87.29. Well, from here over is 87.29. From here over is 38.59. So if I want to find just this segment right here, I'm going to have to subtract those two values. So I subtract 87.29 minus 38.59, and I get 48.7. I already had it written down, so I didn't grab my calculator, but 48.7 is this percentage right here in between. Okay. We're going to skip example 5. That's just finding the mean and standard deviation. We've already done that. You're going to do some practice problems in your workbook and then some on Delta Math, and that's it.